Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Muhammad ARROYAN. I am from Walisongo, Semarang. Today I will present my Physic project for the International Science Competition, Physic Olympiad, titled Coupled to Spring Analyzed by Kilogram Equation. Let's take a look by the process and the results of this study. From the construct system, it can be observed that there are two masses suspended vertically and connected by the spring. The first spring is attached to fixed stick at the top, which is lower and connected to the first mass, M1. The second spring connects the first mass, M1, to the second mass, M2, and the bottom. In the equilibrium state, the first spring supports the total weight of both M1 and M2, while the second spring only supports the weight of M2. When the second mass M2 is pulled downward in the release, the system undergoes vertical oscillator motion. Because the two masses are coupled through the second spring, the oscillation of M2 also influences the motion of M1. The result in a coupled system in which both masses oscillate in a mutually dependent manner through the changing length of the spring. The spring in the system serve as elements that store elastic potential energy and function to distribute force between the mass, governing the overall up and down dynamic of the system. Constraints and degrees of freedom. The constraints in the system are 4. Point 1 x1 equals 0. Point 2 x2 equals 0. Point 3 z1 equals 0. Point 4 z2 equals 0. The degrees of freedom in the system are 2. We can determine the degrees of freedom using the following equation. T of F equals 3 times n minus k. T of F equals 3 times 2 minus 4. T of F equals 2. And the general coordinates are L1 and L2. The equation of the motion of the system. General coordinate L1 equals x1, L2 equals x2 minus x1. The oscillation speed or the first and second object are respectively x dot 1 equals tx1 divided by dt. X dot 2 equals dx2 divided by dt. Thus the kinetic energy of the system is T equals half m1 x dot 1 squared plus half m2 x dot 2 squared. Potential energy of the spring increase in leg of spring 1 x1 increase in leg of spring 2 x2 minus x1. V spring equals half k1 x1 squared plus half k2 x2 minus x1 squared. Gravitational potential energy spring 1 carries a load m1 plus m2. Spring 2 carries a load m2. V gravitational equals m1 plus m2 gx1 plus m2 gx2 minus x1. V potential total equals half k1 x1 squared plus half k2 x2 minus x1 squared plus m1 plus m2 gx1 plus m2 gx2 minus x1. The Lagrangian of the spring and load system we have is L equals T minus V equals half m1 x dot 1 squared plus half m2 x dot 2 squared minus half k1 x1 squared plus half k2 x2 minus x1 squared plus m1 plus m2 gx1 plus m2 gx2 minus x1. Next, use the Lagrangian equation which has the general form d divided by dt partial L divided by partial k dot 1 equals partial L divided by partial k1, where k can be x1 or x2. Point 1 x1 t divided by dt partial L divided by partial x dot 1 minus partial L divided by partial x1. Partial L divided by partial x dot 1 equals m1 x dot 1. Partial L divided by partial x1 equals minus k1 x1 minus k2 x2 minus x1 minus 1 plus m1 plus m2 g minus m2 g d divided by dt partial L divided by partial x dot 1 equals m1 x double dot 1. m1 x double dot 1 equals minus k1 x1 minus k2 x2 minus x1 plus m1 g. Point 2 x2 t divided by dt partial L divided by partial x dot 2 minus partial L divided by partial x2. Partial L divided by partial x dot 2 equals m2 x dot 2. Partial L divided by partial x2 equals minus k2 x2 minus x1 plus m2g. d divided by partial gt partial L divided by partial x dot 2 equals m2 x double dot 2. m2 x double dot 2 equals minus k2 x2 minus x1 plus m2g. By using the Lagrangian equation, we can get two equations of motion. m1 x double dot 1 equals minus k1 x1 minus k2 x2 minus x1 plus m1g. m2 x double dot 2 equals minus k2 x2 minus x1 plus m2g. An application of the couple-to-spring system can be found in car suspension, where the car body and the wheel acts as two masses, and the spring and shock absorbers function as two springs that work together to dampen vibration as the car moves on the road. Thanks for listening. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.